So, good morning, everyone, and welcome to today's class. In the last class, we had discussed the types of equilibrium. We had seen what type of equilibrium are there and how do we find out whether the equilibrium is stable or the equilibrium is unstable. The first step is to find du by dx. Then, when you find du by dx, which is in yellow, the question that we had done, then you equate du by dx to 0. You solve the equation and you get your values for x, where du by dx is 0. In the question that we discussed in the last class, there were 2 points where du by dx was 0. Then you find out the second derivative, d2u by dx square, and you simply put the value of x in both the cases. As I told you that if there is 2 points of equilibrium, if one is stable, the other one has to be unstable. So once you get one answer as stable, the other answer has to be unstable. Okay, now we are done with this part, and now what we'll do is we will do some points on springs, because springs is the topic that dominates the question of the questions in this chapter, spring and circular motion. These are the two questions that are predominantly there in exam, as well as in the board, in your class exams, as well as in IIT-JEE or NEET. So we'll now try to go through and see something about springs, and then we'll solve some problems on that. We also need to do circular motion, so that would be the last part of this chapter. Okay, I hope you can see this. Okay, there is a problem here, I guess. Let me change it. Just a moment. Okay, it should be like this. Okay, so this is what we got to do today. Elastic potential energy, or basically spring potential energy. We have already seen this in great details. Just wrong here. We have seen this in great detail. We have seen this in great details. We'll just again go and see some important points about spring. So if you have missed anything, you can now revise it. As you can see here, this is a spring which is in its natural length, and a body of mass m is attached to it. If the spring is at its natural length, there is no force acting on the block. But if I now extend it, as you can see, it has been extended by x amount. So what will happen? The spring will apply a force which will try to pull it back. Some people also call it restoring force. And that value of that force is minus kx, this minus sign indicating that it is opposite to displacement from the mean position. This position where the spring is relaxed is known as the mean position or equilibrium position. Mean position, this is a term that will come to you in the chapter of simple harmonic motion, SHM. You can call it mean position or equilibrium position. Mean position or equilibrium position simply means that the force acting on the spring, force acting on the block is 0. So basically, the mean position or the equilibrium position of this body occurs when the spring is in its relaxed state. Now from this state, if I extend the spring, it will try to pull it back. If I compress the spring, it will try to push the block back. The force acting on the block or the force applied by the spring will be minus kx, minus indicating that it is opposite to the direction of displacement. Do we understand this? This k is a constant which is known as the spring constant. We know this, yes or no? Okay, I would ask you now to note these things down. Note these things down. You have to draw these three diagrams. This is the mean position. It has been extended. Here it has been compressed. So draw the three diagrams and draw the direction of force. In case number 2, direction of force is pulling. In case number 3, the direction of force is pushing. So you got to write this. You got to write this. I'll give you 2 minutes to do it. Everyone understands this? Everyone understands this? Mean position or equilibrium position occurs where spring is in its relaxed state. I'll give you 2 minutes. Please note it down. Have you noted it down, everyone? Questions on this spring is are always there in the chapter of SHM and this chapter work, power and energy, WPE. So this is an important topic that you must carefully do. 1 more minute I'll give you to write it down. I hope you have written this. Shall we move again? Please raise your hands if you have written this. Did you get this sheet? Did you get this sheet with you? You have this sheet? Yes, no,
No, sir.
no. You did not get this sheet with you?
Yes, sir. We didn't get that.
You got it now?
No, sir. We didn't get.
Didn't get. Okay. Okay. What I'll do is, I will put it on. I'll put the soft copy in your group, so at least you can have a look at the soft copy. Okay. And I'll ask the office people why the sheets are not distributed. Okay. I put it
Yes,
in
sir.
the Telegram group. You can have a look at this. Okay. Shall we move further ahead? You have noted it down.
Yes, sir.
Okay. Great. Now, the next thing is the expression for elastic potential energy. We are all well aware of it. There is a simple sub proof why it is half kx square, and I will just not go into the proof because it will not serve any purpose. If you can see, how does this energy come into picture? If I have to stretch the spring, if I have to stretch the spring, I will have to do some work. As you can see here, there is work. If I have to stretch the spring, I'll have to do some work. That work is stored as energy. And how much is that work which is stored as energy? It is simply equal to half kx squared. And this is a proof for that. Force is k into x. Force is k into x. We have just seen that. Into dx. We integrate it from 0 to x and we land up with this work done as half kx square. So this is the formula for work done. Instead of calling it as work done, this is the formula for elastic potential energy stored in the spring. Now remember, there was a question in the paper where force and displacement were given and you were supposed to answer in which case the energy or something is more. So how to do this? That question, see, this is how it has to be done. There are three different formulas that you can formulate for the elastic potential energy. The first formula we all are aware is half kx squared. The second formula which you had to find out on your own in the paper was half f into x. How does this formula come? You just substitute k as f by x. As soon as you substitute k as f by x, this formula number 2 comes into the picture. Formula number 3 comes into the picture from formula number 2 when I substitute f by k for the value of x. Remember, f is equal to kx. I am writing it magnitude wise. F is equal to kx. I can substitute x as f by k. I can substitute k as f by x, or I can substitute f as k into x. That will give me three different formulae for energy stored in the spring. The first formula is half kx square. It has only k and x. The second formula is half f and x. It does not have k. The third formula is f square by 2k. It does not have any x coming into the picture. So I'll ask you to note it down from here to here. And remember these formulae, you will need them in a lot of cases. Give you 2 minutes to note it down. If you have any problem, any doubts, please come up. Have you noted it down, everyone?
Yes, sir.
Great. Then let us move forward and do one or two problems straight away. This is the problem that we are going to do, problem number 35. I think one problem is good enough for you to understand this. A long spring is stretched by 2 centimeters. The energy is U. Now it is stretched by 10 centimeters. What will be the energy now? Simple question. Should not take much of your time. Please solve it. Everyone got the answer? So, how to do this? It is pretty simple. Spring is same. Spring constant will be same. Energy stored in the spring is half k squared. Since spring is same, k is same, I can write energy is proportional to x squared. So energy in first case will be half k into 2 squared. Energy in second case will be half k into 10 squared. You can find the ratio u2 by u1. It will be 10 by 2 ka squared. That is 5 squared. 5 squared is 25, and you have your answer as 25 times u. That will be the energy stored in the spring. If the energy stored in the spring when the extension is 2 centimeters is u. Do you all understand this? Can I have some raise hand? Let me understand this. Simple question. I see hand raised on the back benches. Okay. Now remember this question had k and x coming into the picture. Now I'll give you one more, and this is of the type where probably I gave in the examination hall and you had to think about it. Question number 37. Question number 37. Two springs, so they are different springs. Two springs of spring constant 1500 and 3000 Newton per meter are stretched with the same force. Are stretched with the same force. Force is same. They will have potential energy in the ratio of what? Simple question. Force is same, and we have to find the ratio of the energies. I'll give you 2 minutes to solve it. Well, I hope you have done this. The same question, similar question had come in your test the previous week. So how to do this? Now here, remember half kx squared is not the formula that we are going to apply. Here they have talked about k spring constant, and then they are talking about same force. So we have to apply the formula where you have only force and spring constant coming into the picture, and that formula is F squared by 2k. Energy stored in the spring is F squared by 2k. So energy 1 divided by energy 2, if you divide the two energies, it will be F and F will get cancelled because F is common, F is same. You will have U1 by U2 will be equal to K2 by K1. This is what you will get. When you solve it, you will get the ratio as 2:1. Do we understand this? Everyone got this? You got this? Okay. Now, if you got this, what we are going to do, is elaborate more on the spring and do something more on springs. Now that whatever we are going to do may not be useful for this chapter, but definitely when you get on into the chapter of SHM, you will be requiring this. Since we are doing springs, so it is better if I solve if I tell you this concept as well. So what is this concept known as? It is known as wrong color. It is known as the combination of spring. How do spring combine? Combination of springs. What do you mean by combination of springs? Now this combination of springs is similar to a concept that you have already read probably in the 10th standard. Series and parallel combination of resistors. Have you read about this? Yes or no? Series and parallel combination of resistors. We know about this. Parallel combination of resistors, series combination of resistors. No, it is there in 10th standard. Electricity is there in 10th standard. Series parallel combination. You have not read. Okay. If you have not read, nothing can be done. Anyways, the first type of combination that we are talking about here is known as series combination. Now, what do you mean by this series combination? I hope you are noting it down together with me. This is a wall and floor, and I have two springs. It can be more than two springs as well. I am just making it as two. It can be three, it can be four, it can be n numbers. Now, two springs are attached like this. The spring constant of first spring is K1. The spring constant of second spring is K2. Now, that is how it looks like. Now, this type of combination of springs is known as the series combination of springs. Now, what is the special thing that you must remember about this? For example, if I move this block by an amount x, I will ask you a question now. What do you think will be the extension in both the springs? Will it be same as x or will it be different? Two springs attached to a block and I'm moving the block by x. Can you tell me what will be the extension in the spring? Will it be x or will it be will it be different than x? Anyone? Please let me know. Will it be x? Will it be different? Anyone? I move this block by x. What about the extension in the spring? Any idea? Okay, the extension in the spring will be different. If this spring extends by x2, let us assume that this spring will extend by x1. So they will have different extensions. But if I talk about the force acting on the spring, this spring will try to pull it back. This spring will also try to pull it back. So both the springs will be trying to pull it back, and the force acting on both these springs, the force acting on both these springs, F, the force acting on both the springs would be same, but the extension in both the springs would be different. Such combination of springs is known as series combination. Such combination of springs is known as series combination, and it is very easy to see that x1 plus x2, if I add these two, x1 plus x2 will be equal to x. x1 plus x2 will be equal to x. So what happens in this series combination? What happens in this series combination? Point number one, extensions are different. If it is extension, there will be extension. If it is compression, it would be compression. Number two, force is same. So same force acts on it. Same force acts on the two springs. Force in the spring is same, but the extensions are different. Two things that you must remember. Point number three, x1 plus x2, extension in both the springs will be equal to x, the total extension. Remember that. Point number four, if I talk about F, which is the force in the spring, that will be equal to K1 into X1. That will also be equal to K2 into X2. These are the points that you must remember about the series combination. Do we understand this? Can I have some reason that we understand this? I'll give you 2 minutes to note it down. Then we'll move ahead. Have you noted it down? Okay. These are two springs. If there are more than two springs, the same thing will be getting added up. 3 springs, 4 springs, 5 springs. Okay. Now the point here is why it is known as the series combination. Extensions are different, but forces are same. Now, what I can do here, and which is of much importance, that oops, what I can do here, why it is known as series combination. If you had seen the series parallel combination of registers, you could have easily understood this, but doesn't matter. I will try to make you understand. Now, since I understand that this is a series combination of springs, which is same as, in a way, series combination of resistors or series combination of capacitors or series combination of inductors, which will be coming in the next year, I can replace this combination of two springs. There are two springs, remember. I can replace this combination of two springs by a single spring. So these two springs have been replaced by a single spring. Now the single spring has a spring constant Ks. Let me call it as Ks. S standing for series. Ks. Now I have extended this by an amount x. This spring will also extend by an amount x. Do we understand this? Instead of two springs, now I have one spring. So if I extend the block by x, the spring also gets extended by x. Do we understand this? Yes or no? Okay. Now, what I'm going to do here, just draw a line. Okay. Now the spring constant Ks, if I have to find out the spring constant for this, how will I find it? 1 by Ks will be equal to 1 by K1 plus 1 by K2. This is how you can find out the value of the spring constant. If I want to make it a general formula for more than two springs, I can write it like this. 1 by Ks, S standing for series, will be equal to summation of 1 by Ki, I varying from 1 to n. This will be the general formula for finding the spring constant of the series equivalent spring. Also remember that F, which was equal to K1 into X1, which is also equal to K2 into X2, you can also write it as equal to K S multiplied by X. All these three quantities are same. I hope you are able to understand it. I have replaced both the springs, the combination of springs, by one spring. The spring constant of that spring is Ks. You can call it K whatever, or K equivalent. How do I get the value of this Ks? 1 by Ks will be equal to 1 by K1 plus 1 by K2. If you have more than two springs, just keep on adding 1 by K plus 1 by K plus 1 by K and so on. Remember, the force in the spring, force in both the chota spring and the bigger spring, they are all same. So K1 into X1 is equal to K2 into X2 is equal to Ks into X. I'll give you a minute to write it down. If you have any problems, please ask. Have you noted it down, everyone? Well, if you have noted it down, we shall now move on to the next heading. We have seen one combination which is a series. So the other combination is now known as the parallel combination of springs. Now, how is this parallel combination possible? I have a block of mass M. Now the springs are attached like this. Now the springs are attached like this. This spring is K1 and this spring is K2. Now I hope you can understand the difference between the two. Now if I now move this block by an amount X, if I now move this block by an amount X, can you tell me what will be the extension in both the springs? It's a simple question. Does not require physics. It requires more common sense than physics. If I extend or if I move the block by X, what will be the extension in both the spring? Can I have some answers?
X, sir.
Yes, beta.
X, sir.
Yes, it's very simple to see here that this spring will also get extended by X and this spring will also get extended by X. So what do we see here? In previous case, the extensions were different. But in this case, the extensions are same. So that is the first point that we note down. The first point that we note down is extensions or compressions are same. In both the springs, I have only put 2 springs. You can put more than 2 springs, doesn't matter. Extensions are going to be same in all the cases. Now let us talk about the force. The spring has been extended, so this spring will try to pull it here and this spring will also try to pull it here. Let me call the force in this spring. Okay, now tell me, instead of me giving the answer, what about the force in the spring? Will it be same or will it be different? Extensions are same. What about force? Same or different?
Same, sir.
Same? No, they will be different. So, force in first spring is F1. Force in second spring is F2. That is what you need to understand, that extensions are same, force is different. So it is exactly opposite of what we had done previously. If I just take you to the previous slide, here extensions are same in parallel combination and force is different. But if I take you to the series combination, you can see very clearly that extensions are different and force is same. So basically series combination is the opposite of parallel combination, or parallel combination is the opposite of series combination. Do we understand this? Can I have some reason that we understand this? Okay, so series and parallel combination. Okay, Jai Shankar, well done. Series and parallel combination are opposite of each other. Now let us look at the formula for this. Forces are different. F1 will be equal to K1 into X. X is same. F2 will be equal to K2 into X. So far so good. Do we understand this? I'm trying to cover each and everything that you need to know about springs. Whether it is useful in this chapter or it is useful in some other chapter, doesn't matter. If it is spring, you must be knowing everything about spring. I hope you are noting it down together with me. So F1 will be equal to K1 into X. F2 will be equal to K2 into X. If I talk about total force F, total force acting on the block, the total force acting on the block will be F1 plus F2. The total force acting on the block would be F1 plus F2. I hope I am clear till this point. I'll give you a minute to note it down. Please note it down. We'll come back. I hope you have noted it down. Now, as we had done in the previous case, we had two springs in series. We removed those two springs, and instead of that, we put one single spring. Here also, we can do the same thing. We can remove these two springs and put one simple spring in place of that. The spring constant of this spring, let me call it as Kp, P standing for parallel, Kp. I have moved this block by x. The spring also moves by x. How do I get the value of Kp? Remember, Kp parallel combination is nothing but equal to K1 plus K2. So I just add K1 and K2 and I get the value of Kp. If I have more than 2, I can write it like this. Kp will be equal to summation of Ki, I ranging from 1, the first spring, to n. What will be the force on the block? The force on the block, as you can see, is F. Now this F can be written as Kp multiplied by x. This is equal to F1 plus F2. F1 plus F2 is K1 plus K2 multiplied by x. So what I have done here is I have given you the proof as well. How do we get Kp is equal to K1 plus K2? This is the way it is done. I hope you have understood the concept. I have replaced these two springs by a single spring, and the value of spring constant for this spring is Kp, which is nothing but equal to K1 plus K2. If you have more than two springs, it will be summation of Ki. I'll give you a minute to write it.
Completed, sir.
Okay, that is good. Then we will do one more point on springs. I don't want to miss on any of the point. So the point is like this. The spring constant of a spring is inversely proportional to its length. The spring constant of a spring is inversely proportional to its length. So basically what I mean to say is K is proportional to 1 by L, or I can say it like this: K into L is a constant for any given spring. K into L is a constant for any given spring. I'll give you a problem on this that will make things clear. A spring of spring constant K is cut into two parts in the ratio 1:2. So the parts are in the ratio 1:2. Find the spring constants. So now instead of one spring, you have two springs in the ratio 1:2. You have to tell me what is the spring constant of the two parts. That is the question. Anyone with any answer? Anyone got any answer? So basically what I have a spring of length L. Spring constant is K. Now I've cut it into two parts. This is part number 1. This is part number 2. If the length of this one is L1 and length of this is L2, spring constant is K1, spring constant is K2. So I've cut it into two halves. L1 and L2 are the lengths of the two halves. I know that L1 plus L2 will be equal to L. Yes or no? Do you understand this? Great. Also the ratio is given. So L1 by L2 is equal to 1 by 2. L1 by L2 is equal to 1 by 2. This is equation number 1. This is equation number 2. From here you can find out the value of L1 and L2. Can anyone tell me what is the value of L1? Simple equations. Can anyone tell me what is the value of L1?
L by 3.
Well done. L by 3. And on similar point, what is the value of L2? 2L by 3. Yes or
2L by
no?
3.
So we have found out the lengths, but they were not asking the lengths. In the question it was asked, what is the spring constant of the spring? Spring constant of this spring is taken as K1. Length is L1. How do I get the spring constant? How do I get the spring constant now? I know the length now. How do I get the spring constant? So for that, I apply the formula or the concept that K into L is a constant. We have seen this. K into L is a constant. K into L is a constant. That means K1 into L1 will be equal to K2 into L2. That will be equal to K into L. Do we understand this? Yes or no?
Yes, sir.
From here, you can calculate the value of K1 and K2. Please tell me what is the value of K1 and what is the value of K2. I leave it to you. You can easily solve this equation and get the
3K
value of
3 by 2K.
K1. Yes, beta?
3K 3 by 2K.
Yes, that is correct. This is 3K and this is 3 by 2K. Well done, everyone. This is exactly what I was looking at. These type of questions are going to come in your exam many times. Since it is a very small thing, people skip it, but I have not skipped it. So if this question comes, well, you could do it straight away. We are doing springs, and in the next class probably we'll be doing some problems on one or two problems on series and parallel combination of springs, so that is also done, and you will not face problem in the chapter of SHM. So we'll do that, and I'll wind up today's class here. The thing that we had to do today we have already covered. The next class we'll move ahead, and I hope to see you there. If there's anything, any doubt that you
Yes,
want to
sir.
discuss, please feel free. I'm here. Class is dismissed. If you have anything, please ask. Have a nice day, everyone. I hope you enjoyed your Christmas vacations as well. 2 days, whatever it was. Take care.